So for this third video, we're going to pick up where we left off. We've already built our hearts domain and our data access layer. Neither of those two layers are doing a lot, but it's all we need for this vertical slice. And so today we're going to tackle the controllers and the use cases layer. Use cases is a bit odd to see as a layer. It's often kind of described in terms of the concept of the use case. And I'm trying something new with having it as a layer on its own. I see it in a couple places, like I see it in the standard slides for onion architecture. And the pattern kind of makes sense as a pattern, and so we'll see how that kind of unfolds. So went ahead and just got rid of the default hello world answer that the .NET Core app's going to have, and adding in MVC. We're not using MVC for any of the Razor or Blazor or any of the .NET generated views or anything like that. Just using MVC to be our router, essentially, and pick up on the attributes that we'll add to our controllers. So I went ahead and created a folder for controllers and a folder for use cases for our two layers. And we'll start with the use case. So couldn't actually find any real documentation on use cases as a pattern or as a layer, even though if you look, like I said, in that onion architecture, or I guess the clean architecture slides, they have a concept of use cases there. And I've seen it in a few different architecture pictures where they have just a block for use cases. And so basically the way I'm interpreting this pattern, and it's probably not going to be the way everyone wants to do things, but I think it's actually a pretty good fit, is each use case is going to be mapped to a single API operation. So what we're doing here is going to basically build a REST API, and every get, put, post, every single API operation that we're going to create, we'll create a use case for. And certainly if our API was going to be large enough, that would fall apart at some point. Although I think people tend to think their APIs are going to be larger than they actually are. A lot of the really popular APIs can manage to get away with just a few endpoints. And certainly for our vertical slice here, we only have a single endpoint, so there's no reason not to have a single use case per operation. Went ahead and create a second class here. So also something that may be frowned upon, having two classes in one file. But this class doesn't really going to exist anywhere else. Essentially what we're doing with our use cases here is we're going to reach into our service layers and data access layers and all the various lower layers, grab all the pieces of information that we need to fulfill the API call, and then wrap it up into some kind of JSON object. So the shuffle deck with shuffle count is just defining what the structure of my eventual JSON is going to look like. We'll have the shuffle count and we'll have a list of cards, and that should be everything we need to get the view that we proposed way back in that first episode. Just went ahead and named the method go, because the name of the use case itself should be pretty explanatory as to what we're doing here, and probably have a pattern where most of my use cases will just be named go. I'll worry about adding in the database access later, just because that's going to require me to hook up the context to everything. So to start with, I'm just going to fix the shuffle count to 0. And that's pretty much it for my use case. We'll just create a new deck, shuffle it, and assign it to our results. And then the controller, I'm naming it main controller. Again, the name of the controller here has nothing to do with the actual domain or application. We're not calling it shuffle controller or anything like that. Controllers I tend to name after the URL patterns, basically. So with any kind of RESTful API, if you're at least trying to pay lip service to the RESTful principles, which I do prefer to do, I could go on about that in a while, but basically your URLs are resources. So you might have /books, /documents, or so on, and they can be created and deleted and removed. So we've just got one resource. All we really need is one operation. And so we'll just call it the main resource. And I'm actually going to map it to /API and not just / because / is going to serve up the actual site itself. And certainly for naming purposes for APIs, there's contention between the, I almost want to call them the hate OAS crowd, or the crowd that tends to prefer to the more strict RESTful principles as laid out when HTTP was first defined. And that crowd doesn't like the idea that a URL maps to an operation necessarily, because the operation should already be specified in a way like the create, delete, put, or post, and that really your API should just be manipulating a set of resources and not a remote procedure call API so much in the sense that you have a list of operations and you're just mapping them to URLs. So again, I do try to at least follow those principles as best I can. So we're representing this API as a single resource that you can get as many times as you want. Every time you get it, you're going to get a unique deck. I'm not actually sure if it's idempotent or not, because we're using random number generators here, so you're going to get a different deck every time you call it. But we're not actually modifying any server state other than that random number generator's pointer. So I guess strictly speaking, it wouldn't be idempotent. But it really doesn't have any strict side effects because our server doesn't really have any real state other than that current pointer for the random number generator. All right, now the controller's done, the use case is done. I'm just going to head run it and see if it works. So you'll see I'm not going so much down the test-driven development route this time, just because it tends to be a lot of work. And actually, that's what the latter half of this video is. Quite a bit of work to get a end-to-end test running that actually is going to be able to test these upper layers. The outer layers tend to be quite difficult to write tests for, as we'll see. So running into a few errors here. Initially, I didn't provide the use case to the dependency injection container, so we added that as a scoped resource. Now we need a random. Providing a random through dependency injection can get a little bit tricky. Now I don't want to just new one up within the code. I do actually want to inject it, because if you call in C# at least, the randoms aren't thread safe, and if you new up a bunch of randoms at the same time, they'll actually all get the same seed. It's not even, I don't think, 1 millisecond. I think it's 100 milliseconds or something resolution. It's a pretty big window, and you can pretty easily get into the case where you're creating randoms that have the same seed if your API is getting a lot of traffic. So what I'm doing here is I'm making one kind of thread safe master random, and anytime I need a new random, I'll generate the seed from this master random. And of course, I'm allowing myself to set the seed on the master random in case I want to use it for unit testing or something like that. And there's other ways that you can handle this. You could also make this a static class, purely static and global. It's a pretty common way to handle this, just like purely static and global is a pretty common way for handling logging. I wouldn't really say either of those approaches are bad. I just try to, almost at this point, I'm trying to avoid static for the principle and as a bit of a challenge than it is necessarily a bad practice. Because creating a static random factory like this would probably be sufficient for even this application. As it gets much more complicated, I don't see that being much of a problem. And if it is, it might be a little bit difficult to kind of unentrench yourself and fix that if you decided it couldn't be static later on down the road. But I'll just avoid all that by making it non-static to begin with. So the services object is the .NET Core dependency injection container, basically. And this block of code will probably grow as the application increases in complexity. This is our, I forget the name, context root, I believe is the name of it. It's that top level class where basically we're just defining what all of our services are and adding them to that dependency collection. And so with the random factory, we have to use a bit of a unconventional way for adding the service. Essentially, we want it to be a scoped service. We want a random to be provided on every single request, and it to be a new random, provided, of course, that request needs a random. But we can't just new up the random. We're going to use our random factory to create it. So this is sometimes called factory injection. Pretty much any dependency injection container that you're going to use is going to have a way to do this. Let's see, what am I doing here? Okay, so just adding in a bit of code so that I can get access to the configuration file. I'm going to go ahead and take in that seed as a configurable property, and won't require it if it's not set. We'll just use the default random seed, which is the one based on the timestamp, and that's probably what will even get used in production. But this will allow me to set it from a unit test when I'm running that way. And now I kind of lost my train of thought on factory. So one of the interesting things with .NET Core, especially compared to some of the other big libraries for creating this type of thing, like Spring Framework. It's actually been a while since I've used Spring Frameworks. They may have come around, but .NET Core is very focused on scoped dependencies, whereas Spring Framework tends to use a lot of sort of global thread locals to control state, which is different from request to request. So with a scoped dependency, essentially what we're saying is create these dependencies on every single request. And then with a global thread local, we're saying that it's only going to be one singleton. Like, for example, if we want to use our random as a global thread local, we would have one singleton random accessor service or something like that. And then we would have a thread local. The random accessor service would be a singleton. It would have a single thread local property, which is the random, and some kind of get random method, which checks to see if that thread local is empty. And if it's empty, it would use the random factory to create it, and that would return it that way. And so they're both two different ways of getting access to a scope specific or request specific dependencies or state. It's also how we'll see eventually if we ever need to access the context of the request itself, so the IP address or anything that's different from request to request. We'll see the scoped dependencies allow us to do that there. And with scope dependencies, it causes a bit of an interesting chain reaction because a scope dependency can only include other, a scoped dependency can only be included by other scope dependencies, I think. I may have that backwards, but it causes a bit of a viral effect where if you start using scoped in some places, you end up using scoped all over the place. So with .NET Core, we tend to basically recreate all of our little stateless infrastructure pieces every single time a request comes in. Now, you might still often have a bit of a bulk of singleton core services in the middle. All right, managed to get enough pieces in there. So we have our scope shuffler. Request comes in, it'll create a new shuffler. It needs a random, so we'll use our random factory to create the new random. That lambda there is the way we're doing that factory type injection. And as we saw a bit earlier in the video, that went ahead and was populating our JSON. So now I'll do my backwards testing where I'm going to go ahead and backfill a test for what I just wrote. So I need to create another basic test layer. We created the DB test layer in the last video. Now we're going to create the API test layer in this video. So the API test layer may be a bit misnamed. We're coming in at the API layer, and we're actually going to go ahead and use .NET Core has a great sort of fake HTTP client, HTTP server libraries. So you can write code to access your API. That would be the exact same type of code you would use to access your API in production, where you're going to create an HTTP client and access it that way, but it doesn't actually create the full-fledged server. It just creates a mock server. So pretty useful. It's not common in a lot of different frameworks. When I do Node servers where I'm writing in pure JavaScript and using Express or something like that, I'll tend to just go ahead and fire up an actual server, which tends to just be a little bit slower is the main drawback. This approach is pretty quick. So go ahead and fix that seed. For the test I'm about to write, I don't even know if it's that important that we fix the random seed, but just good practice for that base test to have it to a fixed value, so I'm not having to worry about it in the future. Make a bit of a mistake here. I don't actually need a custom web application factory until I want to start using the database layer. And the web application factory is basically what I just described to you, that .NET Core tool that allows you to build test servers that aren't actual real servers. If you need to customize the way that server behaves at all, you can use what's called a web application factory or a custom web application factory to customize some of that stuff. So we're creating the custom web application factory here, but we won't actually start using it until we add the database in. So you might notice there's just a little bit of backtracking in the video here. Also took me a little while to make sure I got all of my references correct so that I can use this class because it's part of the ASP.NET Core stuff, and that wasn't in my project to begin with. And again, this configure web host is where this is actually analogous to my program.cs, which I don't know that I've shown very much because it tends to be very boring and straightforward. So you can use this if you were going to do anything custom in program.cs for your actual tests, which again with the databases, what we're going to do is for our API testing, we'll go ahead and use a in-memory database. Since we're not really stress testing the database in any way for this layer of testing, we can probably get away with that and it'll be a little bit faster and more reliable and less complex, which is always the goal, to cut down on that complexity. So all we have to do now that we've got that factory, we create the factory, and then from that we can create a client, and this is actually an HTTP client, which would be the same HTTP client you would use if you were going to access an actual server out there that's running somewhere. Now, the downside for any of these types of tests is that we're going to have to be accessing it using URLs, which makes the test a little bit less clear as to what you're doing. So, it probably wouldn't be a bad idea if our use case is more complex to do any complex testing of that use case using some kind of more pure unit testing layer and not our API test layer. This is mainly just about testing all of the wiring, really basic happy paths. And we don't have a lot of complexity in our unit test as we saw. We just kind of create something, call it, and then throw it into our response. So really there only is the happy path. So we can get away with using this layer to fully test that. And we're not going to need that other test layer at the minute. And that's something you'll want to look out for if you can. It's an easy trap when you're writing testing to kind of over-test, where even if you have a really dumb piece of code in a layer that's not doing a lot, and it's pretty exhaustively tested by your end-to-end tests, it can be a habit where you write the inner tests anyway, and then you kind of have two tests that are testing the same path and not really adding much value. So too many tests can definitely be a bad thing and something you want to avoid. Every single test has a complexity cost, has a maintenance cost, and a lot of really pro test advocates will sometimes forget that. The more tests, the better is not always true. We want to get the minimum amount of tests we need to make sure we've pretty clearly covered the various scenarios that we have. Anyway, so I went ahead and created a basic helper method, get async there. This will be used by all of our API tests that need to do any kind of GET request. It's just wrapping those 3 lines. That's just from experience. I've known that when I write these types of tests, I'll have to make a lot of GET calls, and every time I have to make one, it's the same couple of lines to do it. And eventually there will be a post async and delete async and so on, but right now the API is pretty basic. All we have is that one GET method. And I don't remember if it's here. There's a point here where I get a bit confused if I'm using an async API or a synchronous API, and start writing a bunch of methods with async initially and then deleting it, cleaning back up. That's just how it goes. So what we're doing here is we're saying make a HTTP GET request against that URL, take the response and cast it using newtonsoft.json. So whenever you use the default .NET Core stuff, newtonsoft.json is going to get bundled in there, and it's going to get added automatically to turn your response into JSON. So if you don't do anything custom, all your responses are going to be JSON. And when we do this GET here with our HTTP client, we're going to be deserializing all of those JSON responses using that base newtonsoft.json library. This typo here wasn't intentional. I don't know why I typed 53 instead of 52, but so it is. So anyway, my test is pretty straightforward. I'm just grabbing that response and making sure there's at least 52 cards. Don't need to test that it's been shuffled properly necessarily. I mean, I guess it's possible I could miss that call to shuffle entirely. But like we saw in the last video, testing that something has been shuffled properly tends to be a pretty difficult test. So for now, I think I'll just live with making sure I get the right number of things back. And if I end up with a bug or something that pops up later on, I can always add a regression test for that specific scenario. That's another way that I tend to control which tests I write, is maybe take a fairly lean approach for writing tests when I'm starting. And then once I'm actually working on it, I'll run into bugs, I'll run into mistakes, and adding in regression tests as I run into those. Okay, so now we have that test passed. So now let's go ahead and test the database stuff. So now I'm switching. I'm going to go ahead and write the test first. I should call it twice, and I should see that shuffle count increment. It should go from 1 to 2, because every time I call it, I want that shuffle count to bump up. And now, of course, it's failing because that shuffle count is 0, because I haven't added in any of that actual database stuff yet. And turns out adding all of that in is just another layer of complexity and a bit of a pain to get it running. It's one of those things that's actually easier to add in production than it is to add into that end-to-end testing. This results in a lot of times just a lack of end-to-end testing, which is not a good thing. I'd say a pretty good portion of my bugs are in that wiring layer, and so you want to make sure to test it. Even if you're not testing it exhaustively, if you're at least creating these layers and creating a couple of tests like we're doing here, then you're a lot more likely to add regression tests as you run into bugs and add tests around various integration issues as they pop up. So just modifying my use case where I'm using that app statistics repository that we developed last week and incrementing our shuffle count. Try again, and of course now it's failing because this one is actually just I changed that method to async, but I didn't go and change the controller method to expect async. And that was just one of those error messages that wasn't obvious to me. Had to stare at it for a little bit. .NET Core will allow you to make your controller methods async. I'm still not sure if all your controller methods are async, how much of a event loop driven web server you end up with. I'm curious to kind of experiment with that someday. All right, now there's even more output, and it's even less clear what's going on because a lot of that output was standard out. So I'm going to go off on a bit of a diversion here and see if I can pipe that standard out logging into a log file, because otherwise, if I run unit tests and I have a bunch of different tests at that layer, and every single one of them is generating a bunch of standard output, I just end up with a lot of standard output that's not very parsable at all. Just like we did last time, I want to try and get the logs, all the information for each test into its own file. So once I'm automated and all of these tests are running on some build server somewhere and something fails, it'll be a lot easier to debug if I just go look at the file for the test that fails instead of trying to parse through one rather large, noisy file that might only contain standard out and not any of the logging output or anything like that. Oh, okay. Well, my diversion is not here yet. I'm just adding the database in. Adding in here the real database, because this is the normal startup. And as I get this test running, I'm actually going to start by just using that real database, and then I'll switch it over to an in-memory database once I have that real database version working. So now I need a connection string. And before with the DB test, what we did was we just hard-coded that connection string. And that was okay, but the problem with hard-coding that connection string is that as other people use your code, as you go out and you share it, and people are going to want to run your tests, they're probably not going to have the same password for their database. And it's onerous enough already that you're requiring people to have a database in order to run these tests. A lot of people wouldn't even have that kind of test at all, but I kind of explained the rationale for that in the previous video, which is you really do have to test against an actual database if you want to get anything real out. But since we're already requiring people to have a database, it would be pretty silly to require them to fix their password to a certain value. So we're going to make that configurable for the test. And actually, I like the way that JavaScript handles this. The npm config module, not to be confused with the npm config command, is one of my favorite JavaScript libraries just because it's so simple and at the same time so useful. So I'll sort of emulate it here, but it's not going to be close to it in any way. Essentially what I'm doing is I'm taking the sort of standard .NET Core configuration type stuff and using it in my unit test environment. Probably won't see this too often, but it's pretty useful. Basically saying look in the environment variables and look in user secrets and go ahead and set our configuration variables from those. User secrets is what I'm going to end up using here. It's a not something that's very useful for production, but for development like this, it's kind of exactly what I want, which is it's a way to specify some custom configuration values, keeps them from ever having to be in plain text. I don't really need to keep it secret. I mean, as we've seen from the last two videos, I have no real problem putting that database password out there because that database is not even exposed outside of this machine, so it's not like it's a very secret password. But it is what it is. So in order to use the user secret stuff, we have to go through a little bit of boilerplate here. Populating our project file with a user secrets ID, and then we can use a command line interface for setting properties. Again, I don't enjoy this as much as the config module in JavaScript. There, basically, I would just create a local.json file that, go ahead and turn down some of that noise. A local.json file that contained any local configuration settings, and I could put my database password in there. It's going to be in plain text, but as I said before, that's not really a problem. But we'll go ahead and use the feature since they went through so much work to provide it for us. Essentially, it's this command line API that allows us to set any kind of property you want. Here, we're just going to set that connection string. And actually, this ends up being, looks a little bit silly, but what we're doing is we're defining one environment variable or property for our tests, which we call integration test connection string. And we're then mapping that to database connection string, which is the name of the variable in the actual runtime application. So I say it looks a little silly because we end up having two names for the same thing, but really it is kind of two different contexts. We may, in our DB test, take that same integration test connection string property and use that, and then there is no database connection string property because we're not using the actual startup or application or anything like that. So I often have multiple names for the same thing, but it's a different name depending on the context, and that's not necessarily a bad thing. All right, so now we're actually using our factory here. This is where I mentioned we're going to go ahead and configure that logging so that it goes to its own file. Again, here, I make another mistake. Well, I don't know, so much mistake. It's one thing that's confused me going from, initially I was working in XUnit, and any kind of setup code you just put in the constructor. So I tend to have a habit of doing that. And then I realized I was doing that, so I went ahead and moved it into a setup method just to be a little bit more proper. I'm not sure I really know pros and cons between the two. I think maybe looking for a setup method is a bit more intuitive for someone, whereas the constructor is a bit less complexity, but it's just multiple ways of handling the same thing. There are way too many ways to solve any kind of problem to get wrapped up trying to compare at that level. All right, so now my database is actually getting connected, but I expected 1 and I got 11. That's because I'm using a real database, and the real database had some existing values from when we were doing our testing in the last video. And so once I hit that, that's when I decided that, it probably makes more sense to just go ahead and use a in-memory database anyway. I didn't actually read the error message here. That's why I'm running it again, because I thought it was something that it wasn't. But you can see, again, expected 1 was 11. And now I've got that logger set up, so all of my nice error type, well, not error, but logging information goes here. Keeps my output a lot cleaner. So I don't know if you noticed, but in those console windows where I was running my test earlier, all this stuff was getting dumped to the console window, and for whatever reason, the colors weren't taking. This is actually a little bit ironic and backwards from what I would expect, which is the colors are getting picked up by the log file, and the colors are not getting picked up by the console. But it is what it is. I think Seralog is actually stripping the color information because it knows it's dumping it to a file, and then Visual Studio Code has some kind of log viewer where it tries to infer patterns from your log files and put that color information back in so it's nice and readable. I am kind of pleased with what ended up coming out. All right, now I promised that I would eventually use this class for something meaningful. So here's where we're going to go ahead and override in startup.cs earlier. I added the DB context for the hearts context, and I just said use Postgres. And so what we're doing here is actually overriding that. So this will get run after startup, and there may be a bit of a cleaner way to do it, because startup is actually going to create the factory for a DB context for Postgres, and then we're just going to add on top of it another factory for an in-memory database. And because of the way the .NET Core stuff works, it'll always take the most recent factory you added. So this will get used before the Postgres DB context factory gets used. Probably not a big deal. Maybe it would be nice if we could find some way to prevent that other factory from getting added at all. We could use some kind of test environment property or something like that, but this works fairly well. I'm pulling this snippet from when I was doing this earlier, and when I wrote this earlier, I wrote it in a slightly different pattern. I don't know that I strictly need to do it this way. I'm building a custom service provider that has that test logger factory so that the DB context is using that test logger. But because of the way I just set up the logging for everything, okay, actually I did decide that I didn't need that, so I'm going to go ahead and get rid of it. Okay, so all I'm doing is adding that hearts context. That'll override the other ones. Now we run our test again, and hopefully we don't get 11 this time. Even better. Internal server error. Anytime you see internal server error, a 500 or something like that in .NET Core, you should have some kind of error in your log file. And actually, the error I'm getting here, I think I just breezed through that pretty quickly. This is kind of the end of the video, so we're just committing here. But we can see that error is sequence contains no elements. And this is in here in this query where I'm trying to grab the app statistics. So if you remember from last week, we're doing a bit of an odd thing where our app statistics table is just this table where we're always sort of guaranteed to have one row. And in our DB test, we went through a little bit of a rigmarole to add that initial row. But in the real world, we want some kind of seeding code to add that first row the first time our application starts up, and then on all future runs. We want to either that or we do some kind of find or create every time we try to access it or something like that. But the error we're getting basically is that whatever seeding operation never occurred. So there is no app statistics row in our in-memory app statistics table. So what we're going to do in the next video is we're going to actually create a database seeder to solve that problem. But unfortunately, that's where we'll have to leave off here. All right, thank you. And this video ended up being just as long as the other two, even though I didn't think I was doing very much. Turns out anytime you're doing this kind of infrastructure stuff, there's just a lot of pieces to get in there and get wired up in the right way.